You have just witnessed a lunar eclipse. Our ancestors observed this too. One of them was Pythagoras, a philosopher and an astronomer. He argued that during a lunar eclipse, the shadow of Earth falls on Moon. Since the shadow is circular and covers the entire disk of Moon, Earth must be round. Also, a ship's stern disappears before its sail as it goes over the horizon. Eratosthenes of Cyrene was the first person to measure accurately the size of Earth. He did this by noting the length of shadow of a stick at the same time at Alexandria and at Syene. Well, Moon is the only natural satellite of Earth. It reflects the sunlight as it has no light of its own. Our Earth, is it rotating or static? What is the cause of day and night? More than 2000 years ago, the Greeks, who then had most sophisticated civilization in Europe, believed that the Earth is immovable and it is the cosmos that revolves round it. To understand their view, let's imagine the sky to be a sphere with stars stuck on it and the Earth at the center of the sphere. The Sun and planets also were supposed to revolve round the Earth, though at distances closer than the stars. Claudius Ptolemy, the Alexandrian astronomer, held this view. Ptolemy's Earth wasn't spinning because he thought that otherwise the birds and clouds would be left behind. But there was one thinker who argued differently. The Greek intellectual Aristarchus of Samos argued the Earth that spins from west to east and the cosmos is in fact non-rotating. The 5th century Indian astronomer Aryabhatta sought to explain the observation of westward moving stellar bodies with the analogy of a boat going down a river. In fact, Earth spins from west to east and hence we observe that all bodies rises in the east and set in west. If you stand such that your left hand is towards east and right hand towards west, your face will be towards north and the back towards south. You are now sitting under a canopy of stars. So many stars. Some are faint, some are bright, some are colored. From the dawn of civilization, people wondered at stars. The stars in the sky were imagined forming different patterns called constellations. These patterns resemble certain terrestrial or imaginary objects. Today, astronomers have identified 88 constellations in the sky. Look at those stars there. People imagine them as heavenly twins. They form a constellation called Gemini. Hipparchus, the greatest astronomer, is responsible for creating the first detailed stellar catalogue. He noted down the positions of 850 stars visible to the naked eye. Innovatively, he divided these into 6 classes of importance, the brighter being a first and the faintest sixth. This magnitude system is still used today. Let me now transport all of you inside a time machine. We will leave the Earth on a broad daylight. Wonders in the space are awaiting discovery.
We are outside Earth. Observe our Earth. It is a blue ball in the darkness of space. Earth is rushing through space at a high speed of 30 kilometers per second. Further, did you see? Sun is shining there? But with sun in the sky, how can it be so dark here? We find that the Earth is floating in dark space with stars shining around. Actually, the blue color in the daytime sky of Earth results from the light scattered by dust particles in Earth's atmosphere. Since there is no atmosphere in space, no scattering of sunlight and hence the dark sky. Also, observe there, our only natural satellite, the Moon. It revolves around Earth in about a month. First ever journey by Earthmen to another habitat in our solar system was the Moon. In 1969, Apollo 11 blasted off from Earth for a voyage to Moon with Neil Armstrong, Edwin Aldrin and Michael Collins. Armstrong was the first man to land on Moon on July 21st of 1969. The journey on Apollo 11 took about 73 hours each way, but other astronomical objects are far too remote. How far is Moon from Earth? Before answering it, let us consider the following fact. The fastest means of signal transmission available in nature is light. Light travels a distance of 3 lakh kilometers in 1 second. So, we can estimate the distance of astronomical object by the time taken by light to travel from there to us. 1 light second is the distance traveled by light in 1 second. 1 light minute and 1 light year can be similarly understood. On this scale, the Moon is about 1¼ light seconds away. Another interesting fact is that we can accommodate about 30 Earths between Moon and Earth. The nearest star to Earth after Sun is Proxima Centauri. It is located about 4¼ light years away. Indian Space Research Organization, the apex body for Indian space program, is preparing for the first Indian mission called Chandrayaan-1. Polar Satellite Launching Vehicle, or PSLV, will be used to place it in a polar orbit at an altitude of 100 kilometers above Moon's surface. It is aimed at mapping of the Moon. It is scheduled for launch during September 2007. It would have an operational life of 2 years. Sitting in a hypothetical time machine, we can accelerate time.
Now let us descend on Moon. See the lunar surface features. Water is necessary for life. To colonize Moon, we require water. Indeed, water is found on Moon. In early 1998, USA spacecraft Lunar Prospector was placed into 100-kilometer orbit around Moon. It discovered that the polar regions of Moon have 11 million to 330 million tons of ice. Let's move back to space and observe the 2 planets between Earth and Sun. Let us zoom to the first planet of our solar system, planet Mercury. Its surface is fully cratered. It has no atmosphere. In August 2004, NASA had sent a probe called Messenger to orbit this planet. Next comes the second planet, Venus, named after the Roman god of love and beauty. It has a dense atmosphere of carbon dioxide. Due to the dense atmosphere, it is extremely hot. Its surface is constantly showered with sulfuric acid. A striking feature of this planet is that it rotates retrograde, that is, in opposite direction to that of Earth. Also from Earth, it is the brightest object in the sky next to Moon. So it is called morning or evening star. After Earth comes Mars. Let us take a closer look at the Martian surface. No life of known form is yet discovered in Mars. Olympus Mons, the largest volcano in solar system, is in Mars. After Mars, there exists a belt consisting of rocks and grains called asteroid belt. Next comes the largest planet in our solar system, Jupiter. In it, we can accommodate 1,300 Earths. A striking feature in its atmosphere is the Great Red Spot. At present, 62 moons of Jupiter has been discovered. Let us move next to the Lord of the Rings, Saturn. When Galileo Galilei first turned his early telescope on Saturn in 1610, he first thought the planet had years. But when he looked again, 2 years later, he was amazed to see no years at all. Christian Huygens was the first to suggest that a thin flat ring surrounds the planet. This planet is having least density. If thrown in a great reservoir of water, it would start floating. At present, 33 natural satellites of Saturn are discovered. Next planet is Uranus. It has largely bluish-green atmosphere. The axis of rotation of the planet is tipped almost exactly on its side. This planet has 27 moons. Neptune is the fourth and outermost of the gas giant planets. The storms and winds in Neptune's atmosphere are the fastest in the solar system. Number of known natural satellites is 13. The last planet is Pluto. Not much is known about this planet. It has a natural satellite called Charon. There exists an icy asteroid belt just beyond Neptune called Kuiper Belt. Further, a hypothetical shell of icy protocomets orbits around the Sun. It extends to a distance of almost halfway to the nearest star. It is called the Oort cloud. Well, let's move out of our solar system and see how it would look from far away. Such a wonderful sight. We see planets revolving round the Sun in definite orbits. Here it would be worth remembering Johannes Kepler, who after many trials based on the data obtained by another famous astronomer Tycho Brahe, realized that Mars had an elliptic orbit and that Sun was at one of the foci. These inferences resulted in the Kepler's 3 laws of planetary motion. Now let us move far away from our solar system. See there, our Sun ultimately appears as one among the myriads of stars. Sun is our nearest star. But what makes the Sun shine? The above question is perhaps one of the oldest that has stimulated human curiosity. The huge Sun temple in Konark on the eastern coast of India bears testimony to such belief. Look at those stars. They form the Taurus constellation. Focusing a telescope, there we observe a gas cloud. This is the Crab Nebula, the remnant of a supernova explosion which was observed in 1054 AD. The famous astronomer Subramaniam Chandrasekhar said that after the supernova, if the mass of the star is less than or equal to a limiting mass of about 1.4 times the mass of our Sun, then it would form a type of star called white dwarf. But that is not the end. By the way, if the mass of a star exceeds this limiting mass, then there results a new type of star called a neutron star, as then the star would be mostly made up of neutrons. Further, if the star rotates very rapidly, it is called a pulsar because its polar radiations sweeps Earth periodically and we observe them in form of well-defined pulses. Look there. Remember Crab Nebula? Let us point a radio telescope in that direction. A recording device shows pulses which are very short and well-defined. Neutron stars are only formed when the mass of a star is below 2 solar mass. For more massive stars, the gravity goes on contracting the core. At some point, the density becomes so high that the star's gravitation traps light, which comes close to it. So, it becomes invisible in optical range. Such a star is called a black hole. Look there. It's the constellation of Cygnus. There is a very intense X-ray source there. Astronomers think that a black hole is present there. The intense X-ray is generated as a black hole swallows gases from a nearby companion star. Astronomers have named this black hole as Cygnus X1. Now, as we move away far in our time machine, we suddenly reach a region where we see no more stars surrounding us. But in front of us, we see a vast island of stars. This is our galaxy. We call it the Galaxy or Milky Way Galaxy. Our Sun is a member of this family of stars. You will be astonished to know that such islands consist of about 100,000 million stars. The diameter of our galaxy is 100,000 light years. There you see 2 more satellite galaxies. We call them large and small Magellanic Clouds. Our neighboring regular galaxy is called Andromeda. It looks like this. In fact, during 1920s, astronomer Edwin Hubble classified all the observable galaxies into spiral, elliptical, and irregular. Also, Hubble discovered that the farther these galaxies were, the faster they move away from us. These galaxies exhibit certain associations with some other galaxies and form clusters of galaxies, and the clusters form superclusters. Let us have a voyage to the extreme boundary of our universe. You will be seeing a new variety of object called quasar. The name stands for quasi-stellar radio sources. Astronomers Thomas Matthew and Alan Sandage discovered these objects from Earth through telescopic observation during 1960. From this fag end of the universe, let us return to our home planet, Earth. Life, how did it originate on Earth? Well, the mystery is not yet solved. Astronomer Fred Hoyle suggested that the basic units of life were transported to Earth from outer space through comets. Studying some chemical compositions of comets did reveal presence of biological molecules. We are also in search of extraterrestrial life. The radio telescope in Arecibo is instructed to listen to signal from alien civilization. In the series of evolutionary sequence of living species, human stands apart. From this small planet in the vastness of space, humans succeeded in comprehending so much that appears incomprehensible. India, a country of great potential and wisdom, time and again produced great persons. It did not lag behind in space exploration too. Rakesh Sharma was the first Indian to go to space. Kalpana Chawla, an astronaut of Indian origin, was the first Asian woman to venture into space. On 1st February 2003, she met with her tragic death. During re-entry, the space shuttle Columbia crashed. ISRO has named a weather satellite after Kalpana Chawla as Kalpana 1. In August 2004, NASA too followed suit by naming a supercomputer after her. With time, we will peep more and more into space to learn more about universe. Thank you and goodbye.